Now this type of differential equation is called a homogeneous differential equation. Okay, so let's have a look at this example we've got. We have x minus y, which together is being multiplied by dy dx, and that is equal to x plus y. Now if we have a think about how this could be rearranged, because the x minus y here is multiplied by the derivative, dy dx, we can't sort of subtract one from the other and then collect our x's and y's and that sort of thing. So the only way we can get dy dx on its own is to divide both sides by x minus y. So we've got x plus y over x minus y. Still not an easy way to separate your x's and y's. So what we're going to do is just change this so that we can get it in this form, y over x. And the way we do that is, in this case, to take out a factor of x. So we're left with 1 on the inside plus y over x, and the same on the bottom, x out the front, 1 minus y over x. Okay, so that's our dy dx. The x's cancel, and so we're just left with 1 plus y over x over 1 minus y over x. And here we can see we've got dy dx as a function of y over x. Now the next step we're going to do is to let v, okay, just introducing another variable, so capital V, equal to y over x, which means that we'll have dy dx equal to 1 plus v over 1 minus v. So you think to yourself, well, how does that help? Well, what we're going to do here, let's just work with this here that we have now, v equals y over x. We can rearrange that so that we have y equals x times v. Now to differentiate this function here with respect to x, so we've got dy dx. By differentiating this, we will be able to replace our dy dx, okay, on the left hand side of this equation. Okay, so what we've got here is a product rule. Okay, so v here times the derivative of x, which is 1, okay, plus x times the derivative of v, which is just simply dv dx. So we can now put this here in place of dy dx. So v plus x dv dx equals 1 plus v over 1 minus v. We're now going to rearrange, okay, bring all our v's over to the right hand side so that we have 1 plus v over 1 minus v minus v. So we've subtracted this v, bringing it over to the right hand side. Okay, and then we're just going to rearrange this, do a little bit of algebraic manipulation, and so we end up with 1 plus v minus v times 1 minus v. That way we can have a common denominator of 1 minus v. And then when we expand the right hand side, the v's here will cancel, and we'll be left with 1 plus, because the negative v times negative v, 1 plus v squared, and that's over 1 minus v. So that's what x dv dx is. So where do we go from here? Well, we're going to treat it like previous differential equations. Okay. So in the previous type, where we had the derivative dy dx as a function of x and y, we're doing the same thing here. This time we're differentiating. We've got the derivative dv dx as a function of x and v. So we're going to bring up x over to the right hand side and bring all of this, which is a function of v, over to the left hand side. So we'll have 1 minus v over 1 plus v squared by dividing both sides by this. Okay, essentially it's its reciprocal times dv dx, and on the right hand side we'll have 1 over x. And now we need to integrate both sides with respect to x. So essentially the left hand side will become the integral of 1 minus v over 1 plus v squared dv, and the right hand side is the integral of 1 over x dx. Okay, so how do we go about integrating the left hand side? Well, we can split this into two parts, okay, because this can become the integral of 1 over 1 plus v squared dv minus the integral of v over 1 plus v squared dv. The right hand side obviously still the same, and it's a nice straightforward one. Okay, this one here we can see when we integrate that it's going to become arctan of v. This one we're going to integrate by using substitution. Alright, so that is by letting u equal 1 plus v squared. Okay, so du equals 2v dv. Okay, so that we're going to have the integral of 1 over 1 plus v squared minus the integral of, well, it'll be a half times the integral of 1 over u du, because we needed the 2v here so that we could replace the 2v dv with du. That's why we've got the half out the front. That's equal to the integral of 1 over x dx. Okay, so we can go ahead and do this one, and that becomes arctan of v minus a half natural log of u, but of course u is 1 plus v squared, so we'll just write that as 1 plus v squared equal to the natural log of x plus c. And we know v is y over x, so we can replace that v with y over x. And that's it. Okay, with ones like this, there's no need to try and make it solving for y completely. Okay, we just can't do that, so we just leave it in this form. Now we want to get some questions so we can practice this. If we go to the Watson questions, okay, we're looking at page 65. Questions 55 through 61 are a bunch of mixed questions from ones that you've already worked on, okay, to these last couple of types that we've looked at. Okay, so you need to work through those to practice them, and then after that, okay, in the next video we're going to look at worded type problems, okay, and being able to solve those, and that will be pretty much it, okay, in terms of the types of questions and stuff to learn. Okay, so there's just probably a couple of videos on working through some examples of worded problems. Okay, so we'll stop there.